So we want to take a look at this question here, and we're starting with part A, which says, find the integral of sine theta of cos to the n of theta with respect to theta, where n is not equal to -1. All right. So for this one, I'll do integration by parts. I will say let u be equal to cos to the n of theta and dv by the theta be equal to sine theta. So we can find du by the theta as being minus n of cos to the n minus 1 of theta, and that's of sine theta. All right, so that's what we'll be having. Let me move this a little to the left. All right. And we'll also be having here v being equal to integrating sine theta, we get minus cos theta. And here I'll say let I sub n be equal to the integral of sine theta cos to the n of theta with respect to theta, which therefore means that I sub n is actually equal to, and now we apply integration by parts. So we will say uv, so the product of these two, which if we are to find it, we get minus of cos to the n plus 1 of theta. And that's going to be minus the integral of the product of du by the theta and v. All right. So for this product, we will get, if I am going to factor out n, I'll have n here and the integral of, and if we add up the powers on cos to the n minus 1 of theta and cos theta, we will get cos to the n of theta, and that's of sine theta with respect to theta. So I've done the product of these two, of du by the theta and v. All right. So I think you can also see here that this thing is the same as I sub n. It's actually I sub n. So we have I sub n being equal to minus cos to the n plus 1 of theta minus n I sub n. And if we take this to the left side and factor out I sub n, we'll be having n plus 1 of I sub n being equal to minus cos to the n plus 1 of theta, which therefore means that I sub n will be equal to, if we divide both sides by n plus 1, we'll be getting minus of cos to the n plus 1 of theta over n plus 1. And that's going to be plus c. So this here is the answer. That's the answer. That's how we do it. Let's go on to the next part. The next part says, let I sub m and n be equal to the integral from 0 to a half pi of sine to the m of theta of cos to the n of theta with respect to theta. So on part B, show that for m being greater than or equal to 2 and n being greater than or equal to 0, I sub m and n is equal to m minus 1 over m plus n of I sub m minus 2 and n. All right. So we want to work this one out, and I would want you to consider the fact that on part A, we established that if we integrate sine theta of cos to the n of theta with respect to theta, we got that we get minus cos to the n plus 1 of theta over n plus 1 plus c. So I want you to keep this in mind, okay? Because we are going to need this important result which we got from above. All right. So basically, let me move this down a little. So we will be saying here, for what we've been given, all right? Because the question here is talking about I sub m and n being equal to the integral from 0 up to a half pi of sine to the m of theta cos to the n of theta with respect to theta. All right. So we want to model this thing so that it takes a form similar to this one, okay? So a way we can do that would be to say this is the same as the integral from 0 to a half pi. I think I need to leave a little bit of space, okay, so that everything is clear. So we can say that it's equal to the integral from 0 to a half pi, and I will say of sine theta of cos to the n of theta, all right? But that's not really how it is here, right? So to make this power to become sine to the m as it originally is, I will multiply by sine to the m minus 1 of theta, and that's with respect to theta. So these two things have equal value, okay? If you add up the powers on sine theta and sine to the m minus 1 theta, you get the power m. So it actually has the same value, all right? So how does this help us, all right? This is important because with this thing that we have, we can now actually do integration by parts. Okay, I'm going to let u be equal to sine to the m minus 1 of theta and dv by d theta be equal to sine theta cos to the n of theta. All right. So here we can say du by d theta is equal to, and differentiating this gives us m minus 1 of sine to the m minus 2 of theta cos theta. So I'm using the fact that if you differentiate with respect to x, a power of sine, you get n sine to the n minus 1 of x cos x. All right, so this is the special result I'm actually using here. All right, and here we will get v, all right? Integrating this, we know already that it gives us minus cos to the n plus 1 of theta over n plus 1 as we got earlier. So applying integration by parts, we'll therefore be saying I of m and n should be equal to, and here we'll say uv, which is 1 over n plus 1 of sine to the m minus 1 of theta of cos to the n plus 1 of theta, and there has to be a minus here because there's a minus here, right? So we need to make sure that we don't leave it out. So that's what we will be getting here. And we do have limits, right? So I'll have limits here, 0 to a half pi. And that's going to be minus the product of u and v. So the product of these two, right? So there has to be a plus due to this minus, and the constants, we factor them out, and we have m minus 1 over n plus 1 of the integral, and that's the integral from 0 to a half pi, and that's off. What remains is sine to the m minus 2 of theta, and for the cos, it will be cos to the n plus 2 of theta with respect to theta after adding up the powers. All right. So this is where we are. So I sub m and n should be equal to, if we substitute a half pi in here, we know that cos of a half pi is 0. So that will make this whole thing become a 0 if we substitute a half pi. And we know that sine of 0 is 0. So if we substitute 0 here, the whole thing becomes 0. So this whole thing gives us 0. So what remains is m minus 1 over n plus 1, right? And that's off. Now let's look at this part, right? We can express it as here, the integral from 0 to a half pi, right? And if we look at the I sub formula, this formula that we have right on here, we need to have an n here, and the power of sine can be something, like in this case, m. And just by considering the result that we want to get to, we can say here that this thing is as good as sine to the m minus 2. Okay, let me write it that properly. M minus 2 of theta of cos to the n of theta. All right, this thing. And that's of cos squared theta. So I've just split the cos to the n plus 2 of theta so that this can take the form that we can, put in the I sub formula. All right. And we can say here that this is equal to m minus 1 over n plus 1 of the integral from 0 to a half pi of sine to the m minus 2 of theta cos to the n of theta. And for cos squared theta, that's as good as 1 minus sine squared theta. And that's with respect to theta. So basically, we'll be having m minus 1 over n plus 1 of, okay, now splitting after expanding the brackets, we'll be having the integral from 0 to a half pi of sine to the m minus 2 of cos to the n of theta minus, now, so I've done this by multiplying this. So let me just say with respect to theta, and that's minus, again, m minus 1 over n plus 1 of the integral of sine, and adding the powers here gives us sine to the m of theta. All right. And that's of cos to the n of theta with respect to theta, basically. All right. So therefore, I sub m and n should be equal to this thing here. Okay, actually, let me put m minus 1 over n plus 1, and that's off. This thing can be written as I sub m minus 2 and n. All right. If you really carefully look at the I sub formula here, right? So that's how we can put it. And that's minus m minus 1 over n plus 1. This is just our I sub m n. All right. So that's what we got right here. So I'm going to take this to the left side. And if we do, we will be having, okay, I sub m n plus, okay, plus m minus 1 over n plus 1 of I sub m n being equal to m minus 1 over n plus 1 of I sub m minus 2 n. All right. Do we still have space? We don't have much space, but we can create it, okay, so that we just finish this thing off. All right. So let me just quickly do that. Create a little bit more space. All right. So here, this is where we are. All right. Let me just move this down a little. All right. I think this should be fine. All right. So this is where we are. And if we are going to add this two up, we will get, okay, we can actually have this as n plus 1 over n plus 1. It's just 1. So adding up the, the numerators, we will get m plus n on top. So we have m plus n over n plus 1 of I sub m n, all right, is equal to m minus 1 over n plus 1 of I sub m minus 2 of n. And if we are going to multiply both sides, this side by n plus 1 over m plus n, this side by the same, n plus 1 over m plus n, you find that this 2 will cancel and these will cancel. And now we are left with I sub m n being equal to, these will cancel. So we're left with m minus 1 over m plus n of I sub m minus 2 and n. Now, what we have here is exactly what they want us to prove. It's actually this, all right? So I'll say here, shown. And that's basically how we do it.